All right, so now we're going to work through the gas laws in chapter 13. And we know that the first one that we encounter is Boyle's law. So the first law is Boyle's law. And Boyle's law says that the pressure and volume in one situation is equal to a constant. So therefore, the pressure and volume in a second situation can be set equal to that. If P1 V1 equals K, a constant, and P2 V2 equals K, a constant, then that means that we can set these two equal to each other and we can solve. So the first problem that we're going to look at is on page 443, and this is practice problem number 1. So if you would turn there, please. So this says, the volume of a gas at 99.0 kPa, kilopascals, is 300 milliliters. If the pressure is increased to 188 kilopascals, what will be the new volume? So let's think about this for just a minute. If we compare those numbers, so let's make our chart. So P1 is 99.0 kPa, and volume 1 is 300 milliliters. Pressure 2 is 188 kilopascals. And volume 2 then is what we are trying to determine. All right, so here we have our chart, and we are going to, I'm going to show you 2 ways to solve this problem. All right, so the way that your book works out this example to say, well, we are trying to determine what V2 is. So rewrite the equation. V2 equals, so we're going to divide, we have to get rid of this on this side. So it becomes P1 V1 divided by P2. And then you would fill in. So P1 is 99.0 kPas. Volume 1 is 300 milliliters divided by 188 kPas. Now, before I pick up my calculator, I'm just going to ask us to think about what should we get if we are analyzing this before we even start. If we think about the fact that Boyle's law is an indirect proportion. When one increases, the other one has to go down. So the pressure has increased. So the volume has to go down in order for us to get a reasonable answer. If we get a volume that is larger than our original volume, then we need to logically say, hold up, I did something wrong. So that will help you if you sort of ballpark where that answer is going to fall. So let's grab our calculator. So 99 times 300 divided by 188 equals, oh, we get a lot of digits here, right? So can you see my calculator? So that's 157.9 and then a whole bunch of numbers after. So before, I'm going to go ahead and evaluate. I have 3 sig figs here, I have 4 sig figs here, and 3 sig figs. I can only report 3 sig figs. So I have to, I'm going to round this to 158 milliliters. All right, so I do want to show you what I was talking about in the introductory video about how I would typically solve this problem, and I would talk with you about this if we were in class. So I would take the Boyle's law equation, P1 V1 equals P2 V2. And then I would just take my chart information and fill it in, 99.0 kPas, and this volume is 300 milliliters, equals the pressure 2 is 188 kPas, and then there's the V2, all right? And if you have done this, then I would consider that, because I believe that you understand algebra, then I would count that as you showing me the math, okay? You showing me what you did. So then we would answer, and we know we can flip this around anyway, so then we would write V2 equals, and again, the math would be 99 times 300. I should type the correct numbers. 99 times 300. And since this is connected to the unknown, then it's going to become a divisor, divided by 188 equals, and we round for sig figs, 158 milliliters. We have to put the unit because that's our volume unit. Now, that either one is acceptable. You can see that we get the same answer every time. So you do the one that makes the most sense to you. What I do recommend is this chart, because to not do that can actually, in fact, that's actually needs to happen so that you can adequately fill that in on your equation. All right, so that's one Boyle's Law solved for you. And so your task is to answer number 2 in the practice problem on page 443. All right, the next thing we're going to take a look at is Charles' Law. We're going to find these Charles' Law problems on page 446 in your textbook. So this is problem number 4. All right, and we know that Charles' Law says the volume in the first situation is equal to V2 T2. All right, so here we're comparing, this is a direct relationship between volume and temperature. So question number 4 says that what volume, right? So what volume of gas is in the balloon at the right occupies, will it occupy at 250 K? So this is we have to actually look at this graphic over here. So the volume that we're starting with, the volume that's on the balloon, is 4.3 liters, and the temperature of the balloon is 350 Kelvin. And it says, what is the volume? What will the volume be when the temperature changes? And the temperature is going to change to 250 Kelvin. So the temperature is dropping. So let's look at this in a logical way. If the temperature goes down, the volume should go down. So that's important for us to understand. So let's, from our chart now, fill this in. Again, this is how your textbook would show this. So V1 T1 equals V2 over T2. We're solving for V2. So now these two are going to become multipliers. So if we send this over, if this is divided by, then it will be V1 T2 over T1. This original divisor, denominator, stays a denominator. Okay? So now this is how we would set it up. So we would fill it in. So V2 equals 4.3 liters times, now this temperature is already in Kelvin. So we are ready to go. Now notice this is T2, 250K. Got to be careful about that. It's changed positions, right, because of how we're solving here. Divided by 350K. So now we're just going to pick up our calculator. 4.3 times 250 divided by 350. Again, we get a lot of numbers here. So let's evaluate for how many sig figs our answer can have. So let's look back. 2 sig figs, 2 sig figs, 2 sig figs. So we can only have 3 sig figs. So this is 3.07. So that 7 is going to round that up. 3.1 liters is my final answer. All right. So now, how could you solve this? Once you have your chart written, how could you solve this if you did not want to do the step of rewriting this equation? Well, I would go here. I would say 4.3 liters divided by 350K equals, I don't know volume 2, and then 250K. So now, since these are set equal to each other, that means across this equal sign, we're going to multiply these two So we're going to multiply these two and then divide by the 350, which is exactly what we did over here. But I'm just showing that I know how this math works. So V2 equals, I'm going to go straight to my calculator, 4.3 times 250. I'm not going to write that down because I'm just going to let those sig figs run hanging out in the calculator, divided by 350, and again, rounding for sig figs, 3.1 liters is my final answer. So from the chart, I go here and here. This is the way your book works it out step by step. This is a shortcut for working it out. If that makes sense to you, then you are free to do this to get your answer. If you need all of these steps, please use them, and I would expect to see all of those there as you are solving. Now, let's look at one more example problem here before you get your Charles assignment, which let's do number 5. Number 5 says a gas at 89 degrees Celsius occupies a volume of 0.67 liters. So the volume 1 is 0.67 liters. The temperature 1 is 89 degrees Celsius. It says at what Celsius temperature, okay, so V2 and T2, so at what Celsius temperature will the volume increase to 112 liters? All right, so hopefully you have already thought to yourself, well, before we can solve this problem, we have to change our temperature here to Kelvin because we're not allowed to use Celsius inside a gas law. So the first thing I'm going to do is that I'm going to take 89 plus 273, and so I'm going to do 89 Celsius plus 273 is going to get me to 362 Kelvin. So now I can set up and solve. So I'm going to do this in this manner. So here goes 0.67 liters divided by 362 Kelvin equals, the new volume is 112 liters. What is the T2? All right. So now we see our T2 is down here. So when we cross multiply, this now becomes a divisor. So let's set it up the other way. If we had done T2 equals, so if we're answering for T2, that would be V2 times T1 divided by V1. If you rewrite the equation, that's what it will be. You'll see that's what we're going to, so I'm going to always start, if I'm using this format, I'm going to start opposite my unknown because whatever is connected to my unknown becomes a divisor. So this time I would be cross multiplying here, and then I would be dividing by this because it is connected to here when we think about cross multiplying. All right, so let's grab our calculator and do that. So this is 1.12 times 362 equals divided by the volume 1.67 equals, again, we get a whole slew of numbers here, but I'm going to just write that down. So T2 equals 605 Kelvin. All right, but that is not what if I report that answer, I am incomplete in my response because it said, should have put that there, in degrees Celsius. So now I've got to take the 605 minus 273, 605 minus 273 to get that back to Kelvin, and our calculator says 332 degrees Celsius. Now I'm going to evaluate. Can I report this answer? Well, I have 2 sig figs, 2 sig figs, 3 sig figs. I can only have 2 sig figs. So I am going to report the T2 as 330 degrees Celsius for 2 sig figs.